Hi, everybody. Welcome to Grade 11 University Math. The intent of today's lesson is just to give you an opportunity to knock off some rust, to kind of get back into shape, get rid of the cobwebs, however you want to think of it. This is going to be a very, very quick algebraic review. So you notice the title on today, we got our polynomial review. We're going to go through, we're going to simplify some expressions, we're going to solve some equations. We're going to do the tiniest of factoring. The intent again today is just to get back into shape with some of this material. So, what you see on the screen, there are 3 problems. I'm going to ask you throughout our videos to go through and pause it quite often. And during those pauses, I'd like you to try all of these problems on your own. Okay, through that action of attempting them on your own, what we're doing is we're building up our problem-solving instinct. And what I mean by that is we're learning how to play around with some stuff with our background skills. Okay, we might not be that confident as we work our way through, but what we're going to do is we're going to train our gut instinct with the tools we have to be able to lead us down some good paths as we try to solve some problems. So what you see on the screen right now is our first 3 problems that I'd like you to go through. So you see that the instruction for those 3 problems is to simplify. I would like you to simplify each one of those expressions. Okay, so what I'd like you to do, simplify each one, pause it now. Okay, and we're back. So what we're going to do is we're going to jump in and examine each one of these expressions. Okay, so I'm hoping that we were pretty comfortable to go through and simplify the first one. We noticed that we have 3 terms, and we are asked to subtract each one of those terms. However, we notice that we've got a little bedmass situation within each term. I have my multiply on those first 2 brackets. So in order to follow bedmass, I need to make sure that I simplify the first term. So we're going to expand in that 6. I can simplify the second term by expanding in my -5. Be very careful on your signs there. And then simplify the last term by subtracting every part of that expression. So I would have guessed that a pretty common first line would have been to go through, expand your brackets, to then be able to go and collect like terms. So we can go through, put together all of our x's, and we should get a 10x. And if I simplify my constants, then I think we should get down to a -30. Oops, -24. And as I said, this is about knocking off rust. So hopefully we feel like we're getting back into the swing of things. Now, if after going through the first one, you feel more comfortable to tackle the next 2, then feel free to pause the video at any time and attempt problems on your own. You want to. So what we're going to do then is we're going to jump into B. I'm assuming you're coming along with me. Now, I think the only bad part in B would be if we looked at that squared and we almost scratched it out and wrote down another 2x minus 3. Yes, that's what an exponent 2 means. It means multiply by itself. However, I would hope that we know an algorithm, a process, to be able to expand that white expression all in one step. If you wrote down the red extra bracket, that extra factor, then that's okay for today. Again, we're just getting back in the swing of things. However, I would hope that all of us would be able to go through and deal with the blue in one step. I'm going to highlight a couple things. We should be good to look at that first term and square the first term. So there is my 4x squared. Now we should be good to go through and put the product of the 2 inside terms. So our algorithm then is going to say, now multiply the 2 terms together. So I'm going to multiply my 2x times my -3. That gets me a -6x. And now I double that to get me my -12x. There's my middle term. We can see if we wanted to write out both binomials, that's why we double it, because we're going to have 2 of the exact same term. And now to get my last term, well, then I need to go through and square the last. And so if I square my -3, I get a +9. Watch out for your sign mistake. So as I said, hopefully we're going through and we are simplifying that all without ever writing down the second bracket. That I would really want to see for us to go through and simply know that algorithm and get enough practice with that algorithm. So again, square the first, then multiply them together and double it, and then square the last. Okay, hopefully that algorithm was pretty comfortable for us. And now we could jump in and play around with C. I am going to bet that I caught up with some people in terms of their comfort level, and maybe we need to take another shot at C. So if so, pause it now. Otherwise, I'm assuming you already have a solution for C, whether you're confident or not, and now we're just going through to check our solution. So we take a look at that big ugly expression, and I hope that we can recognize that we have two terms. Recall, terms are separated by addition and subtraction signs, so even though those terms are ugly, I only have two of them. So to add those two terms together, I need to follow BEDMAS, which means I need to simplify each of them first. Let's take a look at that first term. Notice the only really bad mistake you could make here would be to expand in your 2 first. If we expand in that 2, then we are completely ignoring BEDMAS, which means I need to do my exponent before I do my multiplication. So as long as we didn't multiply in, as I get rid of those arrows, that 2, then we should have been good. So my first line may be this, and now I can square my perfect square. Square the first, multiply them together and double it, square the last. Okay, maybe I do the same thing with the last term. My suggestion to you, anytime that I see 1, 2, and 3 factors, so that is 3 things separated by multiply, take a quick peek, pull off the blinders a little bit, and see what makes up those 3 things. Don't just necessarily or blindly multiply them in the order that they're presented. We should be good that if I have 3 things multiplied together, well then I could go 2 times 3 is 6, times 4 is 24. Or instead, maybe I go 2 times 4 is 8, then multiply that by 3. Or maybe I go 3 times 4 is 12, then double it. That is, if all we have is separated by multiply, it never matters what order we multiply in. So you pick the order that we multiply best. And when you take a look at that last term, I think a lot of us would like to keep the monomial out in front. For 2 reasons. In this instance, 2 reasons. The first one is, I don't think I want to multiply my 3 in and then have to expand my brackets, because that's just going to make my numbers bigger. But secondly, look at the 2 binomial factors. Notice that we have the same terms inside each bracket, but with different signs. We have conjugates. Now, I think I might have had some people that didn't use the term conjugate, but instead they tried to call those 2 brackets a difference of squares. Just notice, it's not a difference of squares. When you multiply 2x minus 1 times 2x plus 1, then you get a difference of squares. Look, difference, perfect square, perfect square. They are a difference of squares. However, when I have 2x minus 1 times 2x plus 1, those are conjugates. Okay, I have that blue line, And my guess is that blue line looks an awful lot like question A. Let's simplify that expression then. For most of us, we're probably expanding in that 2, then expanding in that 3, and maybe spending one more line then cleaning up that expression. I would have bet that I would have a lot of that looking on your page. Okay, hopefully that gets us through a little bit of review of expanding some brackets, collecting like terms. In other words, we're simplifying some expressions. Okay, let's jump into something a little bit different next. Okay, I want you to take a look at the screen now because I need you to notice that I've changed one very important thing on you. I've changed your instruction. That instruction for the first 3 problems was simplify. And now I'm asking you to solve. So I have changed that instruction on you significantly. Solving requires something totally different. So what I'd like you to do then is to jump in and try to solve the 2 equations that you see on the page. All of question 1 were expressions. They were never equal to something. They just have a value to them. Well, now we've set our expressions equal. So what allows me to go through and solve is the fact that I have equal signs in each expression. Okay, I want you to give it a shot. So go ahead and solve those 2 equations on your own, and then we'll come back and we'll check. Okay, pause it now. Okay, we're back. So you take a look at the equation given to you in problem A. And I really think that there was only one really bad mistake. And it's taking a look at the right side of that equal sign. The left side of the equal sign should have been pretty automatic for us. That is, I think a lot of people would have liked to have simplified the left side. The big mistake that can come up on that right side right now would be to say 5 minus 3 is 2, and then expand a 2 into those brackets. I hope that you can see that if you were to work through that, you just broke your number 1 rule in math. You just broke BEDMAS. That when you take a look up on the right side of the original equation, you have 2 operations. Those operations are subtract and multiply. We know in BEDMAS, we have to go through and deal with multiply first. And so I've got to leave that 5 out in front, and maybe we expand in that 3. Maybe we spend one more line. I don't know if we like to do this. Feel free if you like. I don't think it's necessarily a bad thing to simplify both sides of the equation first. And now we can go through and solve it. I'm going to bet and say we've kind of got one of 2 paths. That you may be the sort of person who likes to put their variable on the left side. So, to get rid of a plus 6x, you are going to minus 6x. And that's what gives us our negative 8x on the left side. Now, to get rid of your plus 6, we are going to minus 6. And that's what's going to give us our negative 4 on the right side. That maybe you are a left side variable person, and now we could go through and solve that. I would hope that we could skip this line of saying getting rid of times by negative 8 means I divide by negative 8, and we could simply go straight to a negative divided by a negative is a positive, and 4/8 reduces to 1/2. Now, you may also be a positive coefficient person. I would throw myself into that category. That I take a quick peek at my last purple line, and I like to have positive coefficients. So I'm going to think about my variable being on the right side then, because then I will have a positive 8x over there. To get rid of my minus 2x, I need to add 2x. Now that means I need my constants on the left, so to get rid of a positive 2, I need to subtract 2. At the very least, what that does is that allows me to go through and avoid the whole sign issue. Now I can simply jump to get rid of a times by 8, I divide by 8. 4 divided by 8 is the same as 1/2. I would love it if you were the person who wrote this down on your page to work to stop writing this. This always kind of drives me nuts. And the reason it drives me nuts is because I think if we know enough to write the divide by 8 on both sides of my equal sign, then just do it. Now, I'll have a bunch of people who will tell me, no, but I like writing that down. It's good. It helps me. And I'm just going to argue to you, you're just being stubborn a little bit. That is, let's work past stuff that we did in the past that we don't really need to do anymore. If we understand that we're going to divide out that coefficient of 8, then just divide it out. And let's get a little better with the stuff we do. Okay, as I said earlier, I think I probably caught up to some people, or there's some people that feel a lot more comfortable about tackling B. Or maybe the solution you have to B, you might go, oh, wait a second, I want to change that. Well, if that's the case, then I want you to pause the video now, make your adjustments, and then come back and we'll walk through a solution. Otherwise, we are up to speed, and now we're going to walk through a solution to B. Okay, I just want to take a look at one step that you may have tackled at the very beginning. That I'm going to bet and say at the very least, we hit the brakes considerably on B. That is, you look at that and you go, ooh, I got fractions. And so we at the very least went a little bit slower through B than what we did in A. That is, some people may have even said, okay, I have 2 fractions on the right side. I need to subtract those fractions. That means I need to get a common denominator. So I can change 2 into 4 by doubling it. Therefore, I double the top. Like, even writing that down drives me nuts. If you know enough to double it, do you really have to write times by 2 times by 2? So as I said earlier, let's work to be a little bit better. Now, if you went through that process, that then at least allows you to get that right side down to 1 fraction, of which our 2x's cancel out and we're off to the races. I'm going to argue to you, I never solved that equation that way. Now, if you did, there is nothing wrong with that. I might just argue to you, there's a more efficient route. Or maybe a route where you get to manipulate that equation into something you are very comfortable with. So I'm going to erase out all of that red. But if you had something like that, no worries. All I'm going to ask you to do is don't be stubborn and be open to solving that equation a different way. Now, I am hoping that most people, when they see the equation in B and they see all those divide bys, that's the part that slows them down. They're fractions. But the more that we can just see fractions as divide bys, the better we're going to be at solving equations. Because if we're comfortable dealing with opposite operation to the other side, then I think we can get rid of all those divide bys. Notice that for me to get rid of my first divide by 3, that means that I would have to multiply by 3. For me to get rid of my divide by 4 would mean that I would have to multiply by 4. And for me to get rid of my divide by 2, I would have to multiply by 2. Well, actually, I can even shortcut this a little bit. Because if I look up in the top there, my times by 2 is already taken care of because I multiplied by 4 And there's a 2 in a 4. And so if I take a look, I can get rid of all of my divide bys by multiplying by 3 and then multiplying by 4. There's me multiplying by 12. So there's the fastest way for me to get rid of all of my divide bys. Now, I am hoping that in our past, that's been a pretty comfortable process for us. My suggestion to you, though, if you are very used to getting rid of your divide bys by multiplying first, I would just put quick brackets around every term. By putting in those purple brackets, it just reminds you to multiply everything by that 12. So I'm going to multiply the first term by 12, the second term by 12, and the third term by 12. Now, I'm going to have some people that take a quick look at that equation. They go, hold on a second, Gray, you just goofed up. Because you multiplied the left side by 12, but you multiplied the right side by 2 12s. And I just have to stop you there for a second and make sure that we are comfortable that, no, I didn't. I multiplied it by 1 12. I just want you to notice that if I get rid of that second 12, and I get rid of these brackets in here, can you see that really I multiplied both sides of my equation by 12? Multiplying the left side by 12 is obvious, but notice I multiplied the right side of my equation by 12. It just so happens that my right side of my equation has 2 terms. And so if I'm going to multiply that by 12, then I have to multiply the first term by 12 and the second term by 12, and maybe we can see why we had 2 12s there. So I don't ever have to worry about that if I put brackets around every term and then ensure that I multiply every term by that same value. Now, I'm not really going to multiply by 12 because the whole reason I chose that 12 was to eliminate my divide bys. So now I can do my divide by and calculate my 12 divided by 3. That's 4. I can do my next divide by. 12 divided by 4 is 3. And I can deal with my last divide by. 12 divided by 2 is 6. Now, nobody is freaked out by the fact that, hey, look, all those divide bys worked out nice and neat. Because remember, we chose 12 because we knew that all of those divide bys would divide out evenly. Okay. Some people are going to write this next line down and say, okay, well then I have a 4 times an x plus 4. I don't have to worry about my divide by 3. I already did it. Equals 3 times 2x minus 5 minus 6 times x. However, I'm going to argue to you that I would have a lot of people that would be very comfortable seeing that step by saying, okay, I need to expand in my 4. Now I need to expand in my 3. Well, there's nowhere to expand in on my 6, so I just multiply it because it was one term. And notice you could come straight in on the green line. Now, why do I like that? Because that actually looks like an easy form of equation A. And so I just want you to notice before we finish this one off that your best bet to solve an equation that has fractions in it is probably to multiply out those divide bys. Turn it into something that you're quite comfortable with. Now, you can treat that like a good old grade 9 equation and go as fast as you can go. Okay, maybe I simplify the right side. My 6x's are going to cancel out, and I'm left with my negative 15. Now I can get my variable all by itself. Sorry, my variable term all by itself. And now get my variable all by itself. And there we go. So hopefully we matched up with question B. We were able to work our way down. If we did keep the fractions in there for a while, then maybe you were just reminded of a strategy you could use to simplify your equation early. Okay, again, hopefully the rust is coming off a little bit and we're getting back into shape. We're getting back used to working through some of these problems. Okay, let's take a look at our next ones. Okay, I'm going to leave these two up on the screen for you, and same thing. Let's try to work our way through and see what we can remember, see what we're used to. Okay, I want you to solve both of those situations. Pause it now. Okay, we're back. So, for us to take a look at question C, we should notice that we can't put our two variable terms together into one term. We can't collect them. So our motivation then should be to get all of our terms on one side of the equal sign. Now that I have that in standard form, we're hopefully looking to factor. Don't be alarmed if factoring caused a problem. We're going to do a full factoring review, but this will just give you a little bit of an indication of, do we need a little extra factoring practice? I don't care how you go through and factor this. I would just hope that we'd be able to factor it in one step. Use some sort of fast factoring method. So, two numbers that multiply to give 2 would be 2 and 1. Now I'm jumping down. Two numbers that multiply to give 12. Well, I got 4 and 3. Well, if I do this and I go 4 and 3, then when I multiply across, there's an 8 and a 3. That can get me my 5. So all I need to do, if I get rid of those arrows in the middle and then just clean up a little bit, that was my 4, is if I had a positive on the 4, then 2 times positive 4 gives me 8. 1 times 3, if that's a negative 3, gives me negative 3. All I need to do is put in my brackets and my variables, and there I am factored. And therefore, my x is going to give me 3 halves from my first factor, or negative 4 from my second. So, as I said, don't be alarmed if factoring caused us a bit of a wrinkle. We probably have quite a bit of rust buildup there. We're going to deal with a whole factoring review. In fact, 2 days of it. But if we were able to work our way through, hopefully that's what we've got in blue. Okay, take a look at question D, and we should notice that in question D, you've actually been given 2 equations. So we have a system of equations in question D. And anytime we are asked to solve a system of equations, then we're asked to go through and find the value for each variable. So hopefully we've got some good communication and you have labeled both of those equations as equation 1 and equation 2, put a circle around it. That's universal. And I would love it if we used elimination in this case. Like, I would love to see that maybe we doubled equation 1 by multiplying everything by 2. We have now unsimplified that equation, so it becomes equation 3. And between equation 2 and 3, if we were to subtract those 2 equations, our x terms would cancel. Now, I would really like to take equation 3 and subtract equation 2, because then my 2x subtract my 2x cancels out. My 8y subtract my 5y gives me 3y. And my 6 subtract 3 gives me 3. Now, when I go through and solve for y, I get a y value of 1. I can now sub my y value of 1 back into one of my originals. We are probably going back into equation 1 because it's a little simpler. When I do that, I now get x plus 4 times 1, which is 4. And pretty quickly, we're able to get down to an x value of negative 1. And we could then state our solution in alphabetical order down at negative 1, 1. So I would love to see a solution that looks something like that. All of your red is your communication. Make sure that we have that included. If you have something different, then I would have expected a lot of people to just have taken equation 1 and got the x all by itself And now we would have went and subbed equation 1 into equation 2. Wherever I saw my x, I can sub in 3 minus 4y. And maybe you went through and you tackled it that way. If you gave me the green solution, then you defaulted to elimination. If you gave me the blue solution, then you were maybe a little bit of a substitution junkie. You defaulted to substitution. We want to be good with both methods. However, if you're given a linear system, in most cases, elimination is probably going to be a little quicker. Okay, for today, who cares what method you use? I think we're doing great if we were able to solve that system. Clearly, you could finish off solving with the blue. We should be good. We can see the solution that we should come to when we solve that way. Okay, as I said, hopefully we're knocking off some rust. We're getting back into the swing of things. Here's our last problem for today. I want you to work your way through super quickly. Follow the instruction. We're going to factor those two expressions. Okay, pause it now. Okay, and we're back. So hopefully we remember to factor means write as multiply. And so we should have spent some time in grade 10 kind of building up a little bit of a factoring checklist. And so the first question we tend to ask ourselves on that checklist is, how many terms do we have? We notice that we've got 2 terms. And so we go through that checklist, or that decision-making tree, if you want to think of it that way. The first thing I always look for in both my terms, a common factor. And hopefully we can see that our greatest common factor between 12 and 20 would be a 4, and that both of those terms contain an x, so we can factor out a 4x. If I do factor out a 4x, then I can reverse multiply, if you want to think of it that way. What would I multiply 4 by that gets me back to 12? What would I multiply x by that gets me back to x squared? And now what would I multiply 4 by that got me back to a positive 20? I have an x in my factor. I only need to get back to an x, which means I don't need any more x's. So hopefully we got down to that. We know that we are fully factored because if we take a look inside that other factor that we had to build, we notice that it cannot be factored further. Okay, if you need to pause the video to jump into B on your own, then do so. Otherwise, we're just walking through a solution to that one. Between 42 and 70, maybe I look at that and I go, hey, I got a common factor of 7 that I know goes into both of those. And there's at least an a squared in both of those terms. So if I factor out a 7a squared from the first term, that leaves me with a 6a. And if I factor out a 7 from the 70, that leaves me with a negative 10. And we're good. Okay, I just want you to take another peek. Remember, we know that we are fully factored. If we couldn't factor out anything else from the factor we built, and hopefully you can see that in 6a minus 10, we still have a common factor of 2 in there. Don't ever feel like you have to now erase what you wrote down. No, just factor it out now. So all that means is that I missed my greatest common factor. If I pull out a 2 from both of those terms and simplify it with the 7, the best number that I could have factored out was a 14. I'm just going to bet and say, I don't think that we know our 14 times table off by heart. So no worries, factor out a 2 now. And if I take another 2 out of 6a, that leaves me with 3a. If I take a 2 out of 10, that leaves me with 5. And there we go. Okay, there is a little bit of an introduction to a review of factoring. And as I stated earlier, we're going to go through a couple days of factoring review. Hopefully today's lesson worked to get you to just jump in and try some stuff, regardless of your confidence level with it. That we were able to knock off some rust and we were able to kind of feel more comfortable with this stuff again. I think the only bad part about today, even if you struggled to get through every single problem, the only bad part about today is if you simply waited to see me put a solution up. Anybody can copy a solution down. But our goal is to be able to do this stuff independently, even with like little review. So even if you struggle through every problem today, as long as you were trying them, then I think we had a good day and the day served its purpose. Okay, your job, jump in and play around with some practice. Hopefully it goes well. Okay, good luck.